All right, so the second set of special right triangles that we're going to look at are 30, 60, 90 triangles. Now, just like in the last video, we had 45, 45, 90 triangles that refer to their angles. Same thing. We have an angle that's 30 degrees, an angle that's 60 degrees, and an angle that's 90 degrees. You always got to have a 90 because we're looking at special right triangles. So to kind of set up this problem and set up these ideas, I'm going to start with an equilateral triangle. Remember what an equilateral triangle is? An equilateral triangle means all the sides are the same length. And so I'm going to go ahead and drop this equilateral triangle, and I'm going to say all the sides are 8, just to give it a number. Okay. Since all the sides are the same, all the angles have to be the same as well, but they still have to add up to 180 degrees. So if they're all going to be the same and add up to 180 degrees, that means that they all have to be 60 degrees, 60 degrees, and 60 degrees. I'm going to go ahead and draw an altitude. We talked about altitudes a while ago. Second semester we did briefly. An altitude drops down and makes a 90-degree angle. I drop down from the top corner. It doesn't matter which corner we went with. I'm going to go with that one. So you'll notice by dropping that down that we have a 90-degree angle right here. We have a 60-degree angle right here, and if I'm looking at just the left side of the triangle, then what that means is that this top angle up here, which I've got labeled as 60, I'm going to go ahead and get rid of that 60. We'll just erase it like that. Redraw in that line a little bit. That means that that top angle has to be 30 degrees. And so that means that half of an equilateral triangle is the special right triangle we want. Half of an equilateral triangle is a 30, 60, 90 triangle. So I'm going to go ahead and redraw just the left side so we can really focus in on that. So here's the left side of my equilateral triangle. I know that this side is still the original side of the triangle, so that's still 8. This is 90 degrees, this is 60 degrees, and this is 30 degrees. Now, it turns out that when we drop this altitude down, when we drop that vertical line straight down right there, not only did it cut the angle in half, that top angle used to be a 60-degree angle and now it's just 30, it also cut the side in half. And so our original side of 8 got cut in half, so that makes this side only 4. That always happens in a 30, 60, 90 triangle. The hypotenuse, the side that's across the 90-degree angle, that is always going to be twice as big as the shortest side. Now, how do I know that's the shortest side? Because 30 degrees is the smallest angle. Opposite the smallest angle is the smallest side. 30 degrees, a side of 4 is the smallest. Opposite the biggest angle, 90 is the biggest angle, is the biggest side. We know the hypotenuse is the biggest. That's 8. That means that our middle angle, which is 60, in between 30 and 90, that's going to be this side. Now, it's not the fact that, 60 is double 30, and so we can't do anything like that. We can't look at the angles and sides in that manner. If I want to figure out that missing side, I'm going to call that side B. Let's use the actual marker. There we go. I'm going to call that side B. If I want to find B, I can do just like we did in the last video. I can use the Pythagorean theorem. I know the hypotenuse is the side opposite the 90-degree angle, so our hypotenuse is 8, so that's our C. And so if I want to figure out what B is, I can take 4 squared, add to it B squared, and that's got to equal 8 squared. And so just like we did with the 45, 45, 90, if we work that out, 4 squared is 16, 8 squared is 64. If we subtract 16 from both sides, we get B squared is equal to 48. And then we have to take the square root in order to figure out what B is. And so B is going to end up equaling the square root of 48. Now, just like we did on the last video, I can simplify that square root. We did this back in the first semester. I'm going to simplify the square root of 48 as really the square root of 16 times the square root of 3, because 16 times 3 is still 48. Why would I do that? Well, I know the square root of 16 is 4. And so we end up with 4 square root of 3. Check it out. We had the small side is 4. The largest side, the hypotenuse, was twice 4, which is 8. And now we have the other side, the middle side, is 4 square root of 3. Is it coincidence that they both happen to have a 4, or there's a 4 in our answer here for B? No, that's not a coincidence at all. We could go through and set this all up in a bunch of different ways. I think it's better just to kind of give you the setup, because we already did it with 45, 45, 90. And again, I'm just trying to get you the basics to make sure that next year or in the next couple of years, as you get to having to work with trig and integrated 3 and pre-calculus and calculus, these ideas won't be completely foreign to you. So just like we did, I'm going to go ahead and drop the 45, 45, 90 again from the last video. When we had the 45, 45, 90, we knew that if this side was x and this side was x, then this side is x times the square root of 2. That always works with a 45, 45, 90 triangle. So let me get the 45s in there, and there we go. Okay, that's old from the last video. For this new triangle, let's draw it a little bit bigger so that way I can actually write in it. So for this new triangle, for the 30, 60, 90 triangle, we've got a 90-degree angle here. It's very important that we know where the 30 is and where the 60 is. 30 is a smaller angle than 60, and so 30 in this case would be on top and 60 would be there. That's important because then labeling up the sides is something that we need to make sure and do. With the 45, 45, 90, we didn't have to worry about the sides too much because those two sides, x and x, were the same. That's not the case here in the 30, 60, 90 triangle. If we go to the example that we just looked at, one side is 8, one side was 4, and one side was 4 square root of 3. Notice they're all different, and so we're going to have different sides here as well. I'm going to focus on the shortest side. The shortest side is always opposite the smallest angle, so our smallest angle is 30, so the shortest side is this bottom side right here. I'm going to go ahead and label that as an x. If we look at the example, that would be like my 4. And so if we look, the hypotenuse was twice that side. That's always going to be the case because of where it came from. It came from taking an equilateral triangle that we have up here, and we split it in two, right? We divided it in two by dropping down that altitude. That's how 30, 60, 90 triangles are created. And so if that small side is x, then the hypotenuse is going to be twice x. Whatever x is, double it. That'll be the hypotenuse. That only works for 30, 60, 90 triangles. Don't do this for a triangle that has a 90-degree angle and a 20-degree angle and a 70-degree angle. That's not going to hold true, but it holds true when the angles are specifically 30, 60, and 90. Finally, the longer leg, the leg opposite the 60-degree, will be whatever x was times the square root of 3 always. And so let's make that sure that we can see that a little better. X times the square root of 3. We'll put in the square root of 3 first so we can see it, and then the x. There we go. These two pictures you need to have locked in. These two pictures are going to help you when it comes to working through problems with different measurement angles, 45 degrees and 30, 60, 90 degrees. So let's take a look at a few examples of 30, 60, and 90 degree triangles. All right, so all three of these examples that we're going to go through, we're going to try and find side A and B. So the first thing you want to do is find the smallest side. That's going to be your x side. That's the side that you really want to focus in on. The smallest side is always opposite the smallest angle. The smallest angle is going to be 30 degrees. So the side that's opposite that is 6. So when we look at our 30, 60, 90 triangle, let's go ahead and get that here. And poof, like magic, there it is. So once we have that set up, I've got my 6 that is opposite the 30 degrees, and we can go ahead and set up exactly what we have. Our x is like our 6. We can go ahead and write that out if we want to, based on the definition that we have circled on the right. So x is our 6, so then a, based on this picture, a is going to be x times the square root of 3. Because A is the side that's opposite the 60-degree angle. Well, I know that x is 6 because it's the shortest side, so then A is simply just 6 times the square root of 3. To get the hypotenuse, B is going to be 2 times whatever x is, and so since x is 6, B is going to be 2 times 6, and 2 times 6 is 12. So there's our A and our B for this problem. Very, very straightforward and very, very fast. When we know the short side, the side opposite the 30-degree angle, getting the other two sides is fast. It's when we don't have the short side that could require a little extra work, and that's going to be our next example. All right, so our second example. Notice this time around we don't know the short side, we know the long leg. The long leg's opposite the 60-degree. We know the long leg is 11. I'm still going to go based on the picture that's above it, our example, and I'm going to label our short side as x. So A is x, because that's our short side. I don't know what x is, and so I don't know what A is. Can't figure that out yet. Our long side, the 11, that's going to be whatever x is times the square root of 3, according to our rule up top. And so I can now figure out x. All I have to do is divide both sides by radical 3, and x will equal 11 over radical 3. If I utilize my ideas from first semester of not having a radical in the denominator, if I multiply numerator and denominator both by radical 3, I'll end up in the numerator with 11 radical 3, and then the denominator, the square root of 3 times the square root of 3 is the square root of 9, and the square root of 9 is just 3. So there's x. I know that a is equal to x, so we just figured out a. A is 11, whoops, let's get the right marker. A is 11 times the square root of 3 divided by 3. Cool. Now we just have to figure out b. Well, according to my definition that's listed up top in the bubble, the longest side, the hypotenuse, b is going to be 2 times whatever x is. Well, I know what x is. We just figured that out. X is 11 square root of 3 divided by 3, and so then b would be 2 times that 11 square root of 3 over 3. When you multiply fractions, don't freak out. It's just top times top and bottom times bottom, so that 2 is going to multiply the numerator, and the only part of the numerator it can multiply is the thing that it's alike. It's not like the square root, but it's like the 11, and so we end up getting b is 22 radical 3 over 3. So we have a first example where we knew the short side. Our second example, we knew the long leg. Now let's take a look at what happens when we know the hypotenuse. And so, like magic, there's our third example. So notice this time we know the hypotenuse, which is 10. I don't know the two legs. I'm still going to set it up just like our picture to the left of this. I know that the short side A is x, and so let's just state that for now. A is going to be x. The hypotenuse, which is 10, is really 2 times x. Well, that's going to tell me what x is. 2 times x would have to be 10. If I divide both by 2, then that tells me that x is 5. Since a is equal to x, that tells me for sure that a is equal to 5. Well, that was pretty easy. Once I know that, I can figure out what b is. B is the long leg, and we can see from the triangle next to it that the long leg is going to be whatever the short leg is, which we called x, times the square root of 3. I know what x is. X is 5, so b is going to be 5 times the square root of 3. And so we've got our a and our b in that case. A is 5, and b is 5 times the square root of 3, and we have solved this special right triangle. So, when you're doing these problems, you need to look at the example, the definition. Let's call it the definition. This picture right here, and then the 45, 45, 90 picture. You need to look at those specific examples, so that way you can match up the appropriate sides, figure out what x is, and then you'll be able to figure out everything else. So I have some practice problems for you out of the book. So you need to make sure that you have that book, and we'll try and figure out book access for those that don't, because there is an online component, but you really should have the book. And so let me get you that homework assignment, this practice assignment that will help you lock in these 30, 60, 90, and 45, 45, 90 triangles. You want to work on page... There we go, page 458. We're going to do problems 4 through 8, 20, 21, 26, and 27. The first bunch are just the Pythagorean theorem and asking, is it a right triangle? If they give you all 3 sides, you just need to verify that the Pythagorean theorem works. Remember, the biggest side is C. If they give you 2 sides, then you're finding the third side, knowing that it's a right triangle. And then there's a couple of problems that are going to ask you to figure out different measurements based on either 45, 45, 90 or 30, 60, 90 triangle. So work on these and get that 45, 45, 90, 30, 60, 90 examples down, and then we'll move on to how we're going to use these. Until next time, have a great day.